Well, welcome to Unit 1 of Earth Science. One of the topics in this unit is the topics of biosphere and lithosphere and atmosphere and hydrosphere and cryosphere, the spheres of the Earth. In trying to understand how the Earth is put together, scientists have divided the physical components up into units that perhaps we can understand better in terms of how they operate. The atmosphere is responsible for a lot of neat things, our weather in particular. It all starts with energy coming in from the sun. That energy is captured, some is reflected back, and if enough isn't reflected back, then guess what? We're going to get hotter and hotter. That's what global warming is all about. We'll learn more about that later. One function of the atmosphere, that's all the air that surrounds us and surrounds our globe, is to redistribute that heat from the equator where more is collected than in any other place, and then send it north or south towards the poles, and that sets up a system that creates our weather. It also gets sent north and south in the hydrosphere in the oceans. A special part of the hydrosphere is called the cryosphere, that frozen part of the Earth that exists high in the mountains and at far northern and far southern latitudes, permanent ice and permafrost south of that in the north. And, there's a video that you'll see in Unit 6. I may post it here also on the cryosphere. It's pretty important because in some parts of our country, it is where people in the western United States get most of their water, especially from the Rocky Mountains westward. The lithosphere is the soil and rocks and so forth, the mantle of the earth that we live on. All of these spheres interact. And the biosphere is every living thing. But the biosphere is not an ecosystem without the lithosphere, the hydrosphere, and the atmosphere, because an ecosystem contains parts of all of these. And we'll learn more about that later. But an ecosystem is an area that where all of these different physical, which we call abiotic factors, and biotic factors, the living things interact. The living things interact with each other, and they interact with the physical parts of the earth. One of the problems we're having today is that people just seem to think the earth is infinite. The earth is not infinite, it's finite. And as we change things through our use of energy, we are increasing levels of CO2 in the atmosphere. And there's a reason as to why it's a really big deal. Even though the temperature average for the Earth is not heating up that much. But those little things can mean a lot because they get translated into changes in climate and weather patterns. And we've developed our societies, our living locations, our agricultural production systems based on climate that we call normal, which is really an average of many years in the past. And we see now that those averages are getting changed generally to be higher temperatures, longer summers, shorter winters, but not everywhere. Climate change doesn't mean that every place heats up or that it gets hotter and hotter in every place. There's still fluctuation annually. But it does mean that there could be serious effects on weather patterns. There could be serious effects on where we can grow certain crops. So there are economic implications because agriculture is the biggest business in our country. A lot of people don't realize that because so many people live in the cities and so few people live in the rural areas, but agriculture is a big deal. Today I want to share with you a little bit about the lithosphere, and combined with a significant part of the hydrosphere called the cryosphere that used to be on top of the lithosphere in Wisconsin, that is the glaciers. We learn more about glaciers in Unit 6, but at this point in time I simply want to show you some pictures of how the landscape was formed by glaciers in the area where I live. So I'm sort of a lucky guy living in a beautiful area. Okay, so I live just north of Wisconsin Dells in this county. This is Adams County, and you'll notice it says unglaciated here. Well, I live on top of this ridge, and this is as far as the glacier got, and this is the glacial moraine, the line, and then the glacier receded back this way. So I live in a very glaciated landscape in this part of Adams County. As you drive north through Adams County, you come into some, up by Stevens Point and south of Stevens Point even, you start getting into the driftless area and large open fields that are huge and totally different kind of soils and totally different kind of landscape. But I live in these rolling hills that were created by the glacier. So I want to show you some of the pictures of that. And the resource that I'm using, by the way, is the physical environment here by Michael Ritter. I like it a lot. It's got a lot of neat pictures and interactives in it. You can find it by going to www.mritter.net, not .com, .net. So in chapter 819, we'll go to glacial systems. And I'm going to go through several pages till I can find you some definitions of what I want to show you. You'll see there are a lot of different video interactive links and so forth here, embedded videos, which are neat to look at. We're almost there. This is an aerial photo of an area in Wisconsin that's a glacial landscape. It's north of where we are, but it gives an idea of all the lakes, because we're going to be talking about the lakes in the county that I'm in. Adams County and Marquette counties have a lot of Kettle lakes. Now, here are some things we're going to look at. One is a drumlin. This is a good picture of a drumlin. In fact, there's a beautiful drumlin. There's a really neat looking drumlin just like this off of Highway 39. If you're coming south, excuse me, get into the north end of Portage, just as you get to Portage, on the west side, on your right, you'll see a drumlin like this, turned around the opposite way. And that drumlin looks like it's constructed to be a ramp to a bridge going over the interstate. It is not. It's a natural drumlin. It was made by a glacier. As the glacier passed by this way, it left this pile of rock. It separated and left this pile. And we're also going to be looking at an esker. This is a picture of an esker. It's a nice dramatic picture because it goes over water. But an esker is, with an ER, by the way, is a river that was in a glacier, a meltwater river down inside the glacier, and as the water flowed through the glacier, just like a river flows on land, it deposited sand and gravel and rock. And we're going to see an esker. Okay? We won't see a came There's plenty of cames around, but they're forested in my area, so they're hard to see. So we won't see that. Okay, so I'm on the street that my driveway connects with, and I live on a drumlin. And what you're going to see is a few houses and driveways that slope up the head of the drumlin. This is below the drumlin, starting up the hill, so you can see it goes down. We're going to walk over here towards my driveway. This house is close to the road, but you can see it slopes up, and you'll see that the other driveways close to it slope up. There's about 5 houses built on the head of this drumlin. And then we're going to drive down this little road towards Wayne's and around his house. My house is next to his. I have the Pink Lady gravel driveway. So now we're on the south side of this drumlin by Wayne's house. My house is behind his, but we're on the head of the drumlin on the south side of it, and we're going to be just traveling along through this edge of the drumlin, which is forested, and then we're going to see the field that's next to it as I pan the other direction. Okay, there's the field, scoured out by the glacier. Millions of tons of weight of water, hundreds of feet thick, being dragged across this landscape with a life of its own, really. And I want you to pay attention to that ridge. This ridge on the other side of the field. My garden's up here at the end. This ridge goes across this side of the field and then wraps around behind it. Okay, we're down at the other end of the field where my garden is, and right here is the edge of this slight hill, but it drops down real fast behind it, and that is a kettle. That's a place where a block of ice was left as the glacier passed, and then the glacier dragged sand, dirt, and gravel, rock around it. The esker is up here. It's wrapping around that water flowing through the ice, depositing sand and gravel. So here we are on the other side of the garden, looking down into a hole. That's the kettle that was formed by leaving a block of ice as the glacier passed. Now we're going to walk down into another kettle that's just behind or next to the other side of the garden. So we're in the bottom of this kettle, and then I'm going to look up and pan around so you can see this is a pretty good sized kettle. It's only about an acre really, but there's a slope and all of the land is above us, formed by a block of ice being left by a glacier as the glacier passed. In my area, within 10 miles of my house, there are also probably 30 at least of these kettle lakes. Some of these lakes are very deep. Several of them are 90 feet to 100 feet deep. This one's about 95 feet deep. This is Jordan Lake. There's also Deep Lake and several other lakes nearby. We'll take a look at a couple of those real fast. Here you can see Deep Lake. It's a panoramic view from above. It's very steep-sided all the way around. It is developed. It's a pretty lake. It's not very large, but it is a very deep Kettle Lake. And finally, one more Kettle Lake for you to look at and enjoy. There's so many in my area.